Hello students, welcome to the Sarat Chandra Academy. So today we are going to discuss 22 Jan 2026 Shift 2 paper Physics. Okay, so only the memory based questions are there, but still we were almost 95 accurate, 95%. Let's see. Okay, so the work done by force F from R1 to R2 is given by, the work done is this given. Okay, so minus sign is there, that means it's wrong. Okay, in conservative story. There are infinite ways through which we can go from R1 to R2, and work done for each case will be different for conservative force. That is completely wrong. We know in conservative force only how we define the conservative force. This way only, that I am going from here to here, right? Then whatever path I choose, doesn't matter. The work done will come same only, right? That is only the meaning of conservative force. So this is wrong, right? Next. So this is false. Okay, first and both are false. So I can say D option. Okay, then next. In case of capillary action, if surface tension of the liquid radius of capillary and density of liquid decreases by 1%, all of them decreases by 1%. Okay, then percentage change in height of liquid level inside capillary. Okay, let's see. So here we have, let me rough this. Here we have what? If we go by the formula, H is equals to 2T. So radius of capillary cos theta C, cos theta by rho G R, right? So here surface tension is changing by 1%, radius of capillary is changing by 1%, and density is changing by 1% and decreasing. Remember this. Okay, so here if you take ln and differentiate, okay, delta H by H is equals to delta T by T. And here rho will go, radius and rho he's talking about, right? Yeah. So there minus delta rho by rho minus delta R by R. Okay. So by this now put the value. So this is fractional change. If percentage you are talking about, just multiply with 100, then it will come in percentage. Okay. So everywhere multiply in 100, doesn't matter. So percentage. So here delta T by T. So everyone is decreasing by 1%. So this is minus 1%, minus 1. And this is also minus 1, and this is also minus 1. So what do you have? Plus 1, minus 1. So it is plus 1. So you can say 1% increment. Okay. So 1% increment means A option. Got the point? Next. Okay. Next, this logic gate question is there. For given logic gate circuit, select the correct output corresponding to each input. So I hope it is visible. Okay. See here. So here we have AB with the AND gate, and then NOT gate is there, and here CD input with the OR gate, and then after AND with the resultant whatever is coming, they are going through the AND gate and then through the NOT gate. Okay, so one way is, if you get confused in solving how I will solve now, then you can put the input as 1 1 1 1, here 1 1 1 1, and then check the what is the final output. That is very easy. Okay, then you can check for 1 0 1 0, then you can check for 0 1 0 1, then you can check for 0 0 1 1, and then you can take your option. Okay, I will go a little bit faster. Okay, so how we can do this question is, see, if you have the input AB, see here, input AB going through AND gate, so what will come? A dot B, right? Okay, A dot B. Now NOT gate means bar. That's it. Till here agree. So here input came. Till here this came. Okay, this is this thing. Now from here also next you solve CD OR gate. That means C plus D. Right? So this is the input here. C plus D OR gate. Okay. Now here again AND gate. AND gate means between this and this AND operation. Right? So before applying that, what you do is before applying that, you make sure that this also a little bit simplifies. So if you simplify this, what will come? A bar plus B bar, right? So A bar plus B bar and operation with C plus D. Okay, and then NOT gate. That means whole bar. Getting my point? Okay. So now again we will apply theorem. So what is the theorem? How you will say what is the theorem? Let's understand. Basically, any C dot D is there and whole bar is there, that we can write down C bar plus D bar. So that you apply that, like this is the C, this is the D. So So if you do that, what will come here? This A bar plus B bar ka whole bar. Okay, this is the C plus C plus D ka whole bar. Okay, now simplify further. So you can say A plus B ka, now here one more theorem we know, C plus D ka whole bar can be written as C bar dot D bar, right? So by that I can say this is A bar bar dot B bar bar, plus here I can say this is dot C bar dot D bar. Okay, or you can keep it like this also, it is same thing. Okay, so here what came? A dot B plus C bar dot D bar. Okay, now you can put 1 1 1 1 and then you can check what is the answer. Then you can put 1 0 1 0, then you can put 0 1 0 1 0 0 1 1. Okay, so let's try with some options. Let's see what will come. Okay, so if I put A and B 1, A and B 1 1 dot 1 1, and here C and D, so here 0 0, right now 0 and 0, so what will come? 0 and 0 have an AND operation, so what will come? 0, so 1 plus 0 1, so here answer came 1. Then after 1 0, AND operation between 1 and 0, what will come? 0, so here 0, right? And here 1 and 0, so it will become bar is there, so 0 1. Agree? So 0 1 AND operation what? 0, so 0 plus 0 is OR operation between 0 and 0, obviously 0, right? So here also you can see that 1 0 1 0 2 options are there. Okay, let's check further. Okay, so 0 1 0 1, so if 0 and 1 AND operation, what will come? 0, and 0 and 1 they will become 1 0 AND operation, so that will be 0, right? So 0 and 0 OR operation 0, right? 1 0 0 1 0 0 we have to go further, 0 0 and 1 1, so if 0 0 AND operation 0 and 1 1, so bar is there, so 0 0 0 0 AND operation 0, 0 and 0 OR operation, what will come? Again 0, right? So this is 0, so 1 0 0 0, so A option is the correct answer. Okay, this should be clear. Or you can directly go with single input, here get the output, single complete input, then get the output, or you can solve by this way if you understand. Okay, if you get confused in this way, obviously you have to solve in exam manually one by one. That also completely valid. It will take a little bit more time, but if you are not comfortable with this, obviously go with that. Okay, let's go for the next question. This thing, in simple pendulum experiment, gravity is determined by its time period. Okay, which of the following graph is correct? Okay, so it's simple pendulum. If we talk about, then simple pendulum, we know time period is what? 2 pi under root L by G, right? If you will see, he is drawing 1 by T square versus L graph, right? So meaning what? 1 by T square is on Y axis, so 1 by T square you have to take as a Y, okay, and L on the X axis. So what will be the graph? You have to just see that thing. So square, obviously you want the T square, so if you square this will come T square equal to 4 pi square L by G. Then after 1 by T square you want, so reverse it, so you will have 1 by T square is equals to 4, this will 4 will not come, it will go in denominator, so you will have 1 upon 4 pi square L and G will come in numerator. So here 1 by T square is Y, so this is Y is equals to, this is constant, right, and divided by this is the X, right? So now you can see what is this, A option. Agree? So A option is our correct answer. Got the point? There is no negative, nothing. So this will be the graph. I hope this is clear. Okay, next, a metal has work function phi equal to this. When exposed with monochromatic light, maximum kinetic energy of the photoelectrons is found to be 0. Find angular frequency of incident light. Okay, so instead of asking frequency, he asks you the angular frequency, but basically omega, right? That's it. So so he's saying maximum kinetic energy of photoelectrons is found to be 0. That means you say that whatever energy you are giving, hc by lambda, right, that particular photon is going and bringing out that electron out. Okay, that is he have to do phi work function, plus he will have certain kinetic energy. But here he said that this kinetic energy maximum we say for the electron which is just on the surface, right? If you remember the concept. So here we are saying the maximum kinetic energy is 0. So this is not there. That's it. Agree? We have already said that many variations possible in this kind of question. So he gave just this one, right? So if you go for, instead of hc by lambda, you go for h mu, right? So frequency came here. So frequency is what? Phi by h. You can put the value. We are not solving for the value, right? Now frequency is 1 upon time period. Time period is 2 pi by omega. So solving for omega. Omega is 2 pi by time period, 2 pi f, right? This is only the frequency. So this, if you put, what will come? 2 pi phi by h. Okay. Little bit calculation is there, but answer will come. Okay. So you have to get the 2 pi phi by h. Phi given, h given. Okay. We can put the value and we can match the answer. Okay. This was only the concept. Like we can go till frequency. He asked the angular frequency. That's it. Okay. Transmission line having resistance 2 ohm and power delivered is 1000 watt. When potential difference of 250 volts is applied, find efficiency of transmission line. Now, sometimes students get confused. Okay, not that much hard question. Okay, hard obviously not. So now, if you see here 1000 watt power delivered, right, and at the voltage of 250 volt. So first of all, I can say current will come how much? Current is what? Power is what? I into V. So that will be 1000 divided by 250. This will be the current, that is 4 ampere. Right? So 4 ampere is the current. And then after, what we can say? I came. Now how much will be the loss of in the heat? Okay, see here coming 1000. So there is some loss here also in resistance. Like the transmission line is there. In that also there is a loss. So that power loss is how much? Loss I can say I square R. Right? Because resistance is given 2. So this is 4 square into 2. So that will be how much? 4 for the 16, 16 into 32. So 32 watt here loss. And how much you are getting here? 1000. So total how much? Total how much? 1032. Right? And how much he is delivering? 1000. So efficiency, if you will talk about, right? Generally we write down efficiency. So efficiency will be percentage terms he is asking. Doesn't matter. 1000 divided by 1032. This is in fraction, multiply by 100. That will be the percentage terms. Okay. This number when you will solve, it will come approximately equivalent to 96.9. Okay. B option. Got the point? This is what he is delivering. Okay. But actually the power that is coming is 1032, which is like 32 is lost in the wire only. Okay. The transmission line in there only it is lost. I hope so this is clear. In your side level, maybe you can feel like few questions are very hard. Okay, but it's okay. You don't have to go for all questions, even to score 99 percentile. Okay. Find the dimension of the expression epsilon naught E by T, where epsilon naught E and T are permittivity, electric field and time. That's very easy question. Sometimes we try to put for everyone a formula, but what we know, if you are very comfortable with the formula, electric field, directly put any formula of electric field. The basic formula only, if you put K is 1 upon 4 pi epsilon naught, right? And then electric field, then KQ by R square. So KQ by R square. This is what he is asking. So what will come? Epsilon naught cancel out, 4 pi don't have a dimension. So what is there? Charge. Charge he is asking in ampere terms, right? So charge per unit time is ampere, right? And this is length square. So length to the power minus 2. Right, so A L to the power minus 2, you have the A option. Okay, I hope so this is clear. Next, a pulley has mass 30 m. So this pulley have 30 m mass. There are two blocks of masses m and 2m. Find speed of 2m. Okay, find speed of 2m when it descends by distance 3.6 meter. Okay. So if it went down with 3.6 meter down, he went, that time what is his speed? Okay, that we want to know. Now understand one thing, like we don't know this one is disk or what he is considering here. Okay, but by the given information, it is nothing given. And if I see the diagram, I can see that you can consider it as a disk. Okay, so if you will go with the disk, there is an answer which will come. Okay. So if it is coming something else, you can consider that, and then accordingly moment of inertia will change. So currently I am considering it as a disk, okay, of certain radius r. Now let's solve this question. So it have a radius r, assume it will get cancelled out, it will not come. So how you will solve? You will say that at a certain time this pulley is rotating, let's say with omega. At that point this block, 2m mass block will go with a speed v, and m mass block will go above with a speed v, and obviously v equals to r omega relation will be valid. Okay, when he went how much down? Let's say 3.6, consider it h, right? So when he went h height down, he went h height up, right? The work done is done only by the gravitational force, right? So I'm applying the work energy theorem here. So he went h height down, so there is a work done by gravity. He went h height up, so there is a work done by gravity. Now total work done by gravity is equals to change in kinetic energy that you can write down. Initial this system is left from the 0 that you have to consider. Now start. So work done how much? H down. So you can say 2mgh positive work done, and he went h up, so this is minus mgh. This is the total work done is equals to change in kinetic energy. Final kinetic energy when you will write down, obviously both speed will be same, right? String is inextensible, obviously. So if this have a speed v, this also have a speed v. His kinetic energy how much? Half 2m v square plus half m v square. Okay. Then after, kinetic energy of the disk is also rotating, right? So you can say half I omega square, half moment of inertia of a disk. What is that? Mr square by 2. So you can say m is 30m. M r square by 2 into omega square. So omega square, instead of that you write down v by r. Okay, v by r, so v square by r square. So v by r. So you can say here v by r ka whole square. Okay, so let me simplify for you. mgh here, and this is equal to what? Here mv square, here half mv square, and here by 4 is there. See here r square cancel out, mv square is only there. Every time have mv square. Here 30 by 4, that means 15 by 2, and here 1 by 2, that means 16 by 2, 8, and 8 plus 1, 9. So here it will come 9 mv square. Okay, m cancel out. He want what he want? Find speed of 2m mass. Okay, v only he want. So v we can say what? Under root of gh by 9. Okay, so under root g is 10. Okay, h 3.6 and by 9. Okay, so this can be solved. 9 4s are 36, 4 2 meter per second. Okay, 2 meter per second is the answer. So your D option. Okay, I don't know A option what they typed, but 2 meter per second is the answer. I hope so this is clear. Just work energy theorem you apply. This question is also done in the notes. Next, 3 identical bubbles, each having same charge Q. They combine to form one bubble. Okay, so we have to answer the initial potential divided by final potential. Okay, so here one thing, obviously this is memory based, so you have to consider your what we say, you have to consider it as one bubble. This V initial potential when he is asking, okay, this is for one bubble divided by the final bubble. Obviously final one only we have, so here not 3 bubbles we are considering. So initial bubble, if you first of all you find out the relation between radius, so 3 bubble combined and made one, right? So you can conserve the volume here. Okay, so first of all, if you like bubbles, I don't understand, maybe there is a drop. Okay, so if you go with the drop, how you will solve? So 3 times of 4 by 3 pi r cube, let's say earlier it had a small r, is equivalent to 4 by 3 pi r cube. Okay, so here if you conserve, here if you solve, then what will come? Capital R is equals to 3 to the power 1 by 3 into small r. Okay, this relation came between the initial radius and final radius. Now if you write down the potential, okay, so charge Q, okay, so sign initial charge Q everyone, finally what will become on the final one? 3Q, right? So here initial potential when you will write down, you will say K Q by R small r, right? And final potential when you will write down, you will say K 3Q by capital R. Okay, So here if you simplify, Q cancel out, you will have 1 by 3 into capital R by small r. Okay. So here 1 by 3, capital R by small r, 3 to the power 1 by 3. So it is 3 to the power 1 by 3. That means this is 1 upon 3 to the power 2 by 3. So I think the power 2 by 3, A option. Okay. So this way you can solve, but I think here it is should consider the what we said drop. Okay. Bubble, only the water is on the surface. Okay. Charge obviously okay, but how you will conserve the volume? You can't say about the for the volume. Okay. That's next. Time period of revolution of satellite around the Earth depends on density of Earth. Yes, you can bring that thing. Time period of revolution of satellite just above the surface of Earth is given by this particular, where RE is the radius of Earth. Okay, let me solve for you if you don't remember. See, if you just apply the basic thing, right? What is that? Like force towards the center, that is what? G m by r square. Okay, when it is just above the surface, you can consider radius only, is equivalent to mv square by r. But we are going for time period, so you go for mr omega square. Okay, from omega we can go for time period easily, right? So from here, if you solve, m cancel out, your omega will come how much? Here m cancel out, r divide, right? So under root of gm by r cube. Okay. Now if you see directly m by r cube, right? Here you can create the density. This basically density will be what? Rho is equals to what? Total mass divided by 4 by 3 pi r cube. So you can say here that m by r cube, you can call it rho into 4 by 3 pi, just a multiplication factor. So it can bring in terms of radius. Or if you want to solve for time period only particularly, then time period is nothing but 2 pi by omega, which is 2 pi by, this is r cube by gm. Okay, so just reverse of it, nothing else. So time period will bring in terms of radius. Let me get it only. 2 pi under root r cube by m you want, instead of m by r cube by m, so reverse it. So that will be 3 divided by g into 4 pi rho. Okay, so it came in terms of density. That is your time period. Now second statement, he is saying time period of revolution of satellite just above the surface of Earth is given by 2 pi under root. See here, this can also bring in terms of another radius also. Okay, 2 pi under root re by g, small g. Okay, so if you want to create a small g, first of all, small g, gravitational full formula is what? G capital M by r square, right? So if you replace it here, okay, if you replace it here, g m by r square, okay, that is what your small g. So this can be bring time period equal to 2 pi under root r by small g. So I think this is also correct, right? So both statements are correct, and we are bringing it from each other only. So you can say it is correct explanation also. So for the current timing, whatever information and whatever statement is given, according to that we can say A statement correct. Okay. Wavelength of light in water is 540 nanometer. Refractive index of water is 4 by 3. Find wavelength of light in glass, where the refractive index of glass is given 3 by 2. Okay. So now see, sometimes directly say when if you will see somewhere, anywhere, you will see most of them they use formula and directly relation. This is inversely proportional, this is directly proportional. But if you remember the basic formula also, okay, you have to remember only basic formula. That's it. You can solve. Like what I remember here, I know refractive index. He's talking about refractive index. Let's talk about refractive index only. How will I go? How will I go from the refractive index to the wavelength? Right? For that, I have to solve multiple questions from the basic formula only, not from the relation which I should not remember multiple relations from a single formula. Okay. So what we have, refractive index of, let's say, glass, like you can say water divided by refractive index of glass, because I know that things will cancel out. So I'm going from the ratio only. This ratio I know everything. Finally, I will bring in terms of lambda. See how. So refractive index formula, basic formula. What you know? Refractive index formula. You know C divided by velocity in the water, like velocity in vacuum, velocity in water for the light. Divide by C, divide by velocity in glass. Okay, easy. Here solve it. Velocity in the glass divided by velocity in water. Velocity is what? Now you know. V is what? Lambda f, right? And we go from one medium to another medium, frequency doesn't change, right? So that you can use. So velocity is what? Lambda in glass into frequency divided by lambda in water into frequency. This came what? Lambda in glass divided by lambda in water. Okay. Now, generally, if you will see, they say refractive index of water is inversely proportional to lambda. Okay. And a student will also say yes, sir. But if you will ask, 50% of students don't know how. Why? Okay. And that you only have to understand. For JEE Main also and for JEE Advanced also, obviously, you should know why. Exactly, you should know why it is like this. Why we are doing this. Okay. So here I bring refractive index and lambda relation, and that only. He gave both refractive index, he gave one lambda, go for another lambda. So here write down mu of water. Mu of water how much? 4 by 3. Divide by refractive index of glass, that is given 3 by 2. Is equal to lambda of glass. So water he gave, glass he asked only. Lambda of glass he asked, and lambda of water he gave 540. Nanometer only, right? So these don't have a unit. This have a nanometer, so nanometer only will come. So lambda of glass will come how much? This is 4 by 3 into 2 by 3 into 540, right? So this will come how much? 339. Okay. So this will cancel out 339, and here how much? 5, 6. 6 times, na? 6. And here 8, 8, 6, 40. 48, 480. Agree? Yes, 480. Okay. A option. I think, yes, correct. So, okay, 480 answer. That's it. Okay, so you should understand what is that. This is basic thing I am saying. I am just taking an example that sometimes people write down refractive index directly proportional, inversely proportional to lambda, and that's it. Okay. But you should remember on the basics you should not forget. Total kinetic energy of the system can be written as sum of kinetic energy of individual particles from ground frame. Obviously. That is the basic kinetic energy, all kinetic energy addition. Total kinetic energy of the system can be written as kinetic energy of the center of mass plus kinetic energy of individual particle in frame of center of mass. Yes, that is also a statement that we know that kinetic energy total, directly either you add or you say kinetic energy total. Let me write down. Kinetic energy of the system. Either you can directly add individually half mv square for all particles, or you say half m velocity of center of mass whole square. Okay, mass of the system, plus for every single particle you write down what? With respect to center of mass, what is the velocity? Half m v square, half m v square. Here v will be with velocity with respect to center of mass. Okay, that way you can write down. Next, so this is, both are correct. Okay, so D option here. Okay, D option is your answer. Next, for hydrogen atom, if shortest wavelength of Lyman series is 91 nanometer, then find difference of minimum wavelength is the least wavelength, with the shortest wavelength only, of Barmer and Bastian series. Okay, easy question. See here, we say for this one, Lyman series, minimum wavelength means highest energy means from the Lyman means n equal to 1 to n equal to infinity, that is highest energy means minimum wavelength. Okay, so you have 1 by lambda, okay, of Lyman series is equivalent to R into, here Z square will come, that is, doesn't matter, for hydrogen atom is there. Okay, but still if you want to write down, you can write down Z square, and here 1 by n1 square, so 1 by 1 square minus 1 by infinity square. Okay, this is one term. Let me simplify for you because he is asking difference, so we will need the simplified version here. Okay, let's write down here only. So lambda L is equivalent to what? 1 by R Z square. Okay, one only here. That you hold. Next is what? Then find difference of minimum wavelength of Barman and Paschen series. First of all, find out, then we will subtract. Okay. So he similarly write down for the Barman and Paschen series. So you will say 1 by lambda of B is equal to R Z square. Okay. And Lyman Barman. So 2. So 1 by 2 square minus 1 by infinity square. So here this will come how much? Lambda B is how much came? Reverse this. So you will have 4 square. Z gone na? Z is not there here. Z we should not take. Why should we take Z? And Z value we know, hydrogen he said, right? Okay, fine. So this is the value. Lambda will come how much? 4 by R. Okay. Next, your Paschen. So for that you will say 1 by lambda of Paschen is equal to R into, you can say 1 by 3 square minus 1 by infinity square. So you can say 3 square is what? 9. I'm directly writing. Okay. So from here lambda P how much came? 9 by R. Now subtraction you want, right? So if you subtract, what will come? Lambda P minus lambda B, that will come what? 4 by R minus 9 by R minus 4 by R. So this will be what? 5 by R. So 1 by R is how much? Lambda L, right? So that is lambda L. So 5 times of lambda L. And lambda L is given how much? Lambda L is given how much? 91, right? So 91. So 9 5 is 45, 450, 450 plus 5, 455, B option. Okay, that's your answer. Got the point? Okay, I hope so this is clear. Next. For single slit diffraction. Okay, for single slit diffraction, he is talking about if we increase lambda, keeping slit width constant, width of central maxima increase. So first of all, understand what is the width of central maxima. So you remember we have wrote theta is equals to lambda by A, right? So lambda by A, theta above and theta below, that is the maximum central maxima he will make. So from here when you bring central maximum width, right, that will come what? Y. Here if you let me write down properly, this is the A, right? And here central maximum, when he will make the intensity graph, it draws, let's say here to here central maximum, from the middle point you say this theta I am saying as lambda by A, right? So lambda by A, so this side also, so this will come with, so this side, this Y will be how much? This Y. So this Y you can say Y by capital D is equals to sine theta equals to tan theta, sorry, tan theta equal to sine theta equal to theta, that is lambda by A. So this will come lambda D by A. But your, what we say, width of central maxima, that width, if you talk about, that width, if you talk about, that will come 2 times of lambda D by A. Okay, where A is the, this width, okay, and this like you can say opening here, and lambda is what? Lambda is wavelength, capital D is the gap. Okay, you can read the notes for that. Now here see, slit width we are keeping constant. Okay, so if we increase lambda, if you increase the lambda, keeping the slit width constant, okay, A constant, width of central maximum increase. If you increase the lambda, obviously width will increase, right? So A, first part is correct, so this is correct. Okay, 1 is correct. Okay, now second statement, if you will read, this is exactly opposite of first statement, so second will not come, obviously, right? So where 1 will come, where 2 will not come, right? Then after 3, if we keep lambda same, if we keep the lambda same, right, and decrease the slit width, if you decrease this, obviously width will increase, central maximum width will increase, so that is correct. So third statement correct. Okay, so obviously fourth statement will be wrong. So if you will read, fourth statement is exactly inverse of third statement, so obviously fourth is wrong. If we increase lambda by keeping slit width same, so if you increase the lambda keeping the slit width same, intensity of central maxima increase. See, if you will increase lambda, width will increase, right? This width will increase, so intensity will not increase. If you try to understand this thing, you can say like that, that a constant amount of light is coming. Okay, if the same amount of power will distribute in a larger area, obviously intensity will decrease. Okay, not increase. For this particular general cases of the single slit experiment, we say that intensity will decrease only. Okay, that's it. So intensity will decrease, not increase. So you can say only 1 and 3 is correct. That means A option. Okay. I hope so this is clear. Next. For non-paraxial in concave mirror, what should be the position of object from the pole? Okay. If you want non-paraxial, parallax. So in the non-parallax means what? This meaning is that basically where should I put the object? Okay. So that even when I move here and there, still object and image should come at the same places, and that is only one place where it will happen. What is that place? That place is your center of curvature. Okay, so you have to place the object at the center of curvature, then only this will non-parallax will come. Okay, so beyond center of curvature, no. Between center of curvature and focus, no. Between focus and pole, only no. Beyond focus, obviously beyond focus, we can say in this D option only he is counting the what we say beyond focus, right? So like center of curvature position is only counted, the best suitable is the D option for putting the object on center of curvature. Here he is saying center of curvature only, beyond center of curvature, not including, beyond it. Okay, so best suitable option is the D option here. Okay, next. So here D option is correct. Beyond focus means this side. Next. In an open organ pipe, third and sixth harmonic frequencies differ by 3200 Hz. Find the length of organ pipe. Okay. So open organ pipe is there. So if you remember, okay. What you say frequency? You say frequency is what? N times of V by 2L. Right? Okay. Where N is what? Harmonic. Okay. So Nth harmonic. So one is third harmonic, sixth harmonic, and their difference is what? 3200. So you can say 6 times of V by 2L. Minus 3 times of V by 2L. This will come how much? 3200. Okay. V is given. That's it. Your L is your answer. So 6 minus 3, 3. So here 3 by 2 into V is 320 divided by L into 3200. Okay. So here 32 gone. 0 gone. L will come how much? 3 by 20. Okay, so 3 by 20 in meter. So I don't know what he gave, he asked in what units, but this is in meter, and if you convert into centimeter, multiply with 100. So here 100 multiply 5, 5 3 is 15. 15 centimeter will come. Okay, right? So if he asks in centimeter, that's an integer. Okay, or here maybe in decimals you can convert 0.15. Okay, that's it. Next. A ring of radius r in millimeter rotating with 100 radians per second about its diameter. It is present in a uniform magnetic field of 0.5 Tesla perpendicular to the plane of paper. Okay. If electromotive force produced in the ring when it has rotated by 30 degrees is 15.4 millivolt. Find R. Okay. Understand? There is a ring. Okay. And about this diameter, it is rotating like this. Okay, this is basic question. Okay, not that much hard. So here, when you will write down the flux, right? So when it is rotating with respect to time. So you can say the angle that will come after t time. How much he will rotate? Omega t. Correct. If he is rotating with an omega, then how much he will rotate in t time? Omega t. Right. So at any point of time t, how much flux you will write down? You will say magnetic field out of the plane or in the plane. Okay. B into pi r square, okay, into cos omega t, angle between. Okay, theta rotated, so sorry, in t time omega t rotated, so cos omega t. Now differentiate this, so you can say EMF will be how much? Minus d phi by dt. Okay, cos derivative minus sign, and then omega will come out, so you'll have minus cancel out. So what will come? B into pi r square into omega into sine omega t. Okay, this is the point. EMF. Now he is saying at this point, okay, when the omega t is how much? 30 degree. That point of time you tell me the R. Okay, so EMF is given 15.4 millivolts, so 10 to the power minus 3 is equals to B. B is how much? V is 0.5. 0.5 means 1 by 2 into pi is 3.14 into r square into omega. Omega is how much? 100. Okay, into sine 30. Sine 30 will be what? Sine 30 is 1 by 2. That's it. Okay, this is the thing. So from here r square you have to solve. Okay, r you have to solve, and this r will come in meters because everything I put in SI unit. So then that meter you have to convert into millimeter. See, that millimeter you will convert, then our answer will come. So here approximately answer comes, I think integer only comes. Okay, as far as I remember. Okay, here you can solve this. 4 is there, 4 here multiply and 3.14. Approximately, I think 196 or something will come. Okay, yeah, possible. Fine, you can solve it. Okay, that calculation part we are not teaching here, we are teaching the concept. So concept was that much only. That is the basic notes question, one of the notes question this is. In the figure shown below, switch S is closed at t equal to 0, find reading of ideal emitter. Okay, just after S is closed. Now this is the easiest question possible anyone can ask you, right? Here if you see, there is an inductor. So at t equal to 0, right? Inductor will not let the current change suddenly, right? So here he will break the circuit, here he will break the circuit. So the current will pass through here, like this, right? 9 volt battery, and here you can say this is 9 ohm resistor. So what is the current? 1 ampere. Okay, that's it. Okay, V by R. R is what? 9 ohm, right? Because here broke the circuit and this broke the circuit, right? This 9 ohm resistor is there in this circuit. So 1 ampere is the current in starting. That's it. So not even 30 seconds it will take. It doesn't matter. Sometimes what will happen is, I will tell you one thing. Sometimes question looks lengthy. Okay, sometimes question looks like big, okay, diagram with and all. But it doesn't matter. Okay, once you read, if after reading you are feeling like there is a possibility it will take too much of time, or there is a possibility we will make mistake, if 10%, 30% of your mind is also saying that thing, that it is possible we will make mistake, leave it for timing and complete the paper first. And then after come back to that question and then do. Okay, that's the strategy, general strategy we use. A tube carries 1.6 ampere current, has length 2 meter and cross-section area 0.2 mm square. If potential difference of 2 volt is applied and number of electrons per unit volume is 5 into 10 to the power 28, mobility of electron is. Now one thing remember, in current electricity, right, when we bring this formula V equals to IR in the notes, okay, that point of time we did the derivation, complete derivation, okay, from the drift velocity, from there we did the complete derivation. That whole derivation we had 6-7 formulas, like we told, put in bracket that this things you remember, okay, that he have asked yesterday also and today 22 also, right? So you should remember those formula. So similarly here mobility was there. So mobility formula, if you will find out, it was drift velocity divided by electric field. Okay, if you remember, we had I is equals to NEA VD, right? So from there, if you will put the VD value, then it will be I divided by NEA, right? And electric field. So here, if you understand, here voltage is given and length is given, right? So we can say that across this voltage potential difference and electric field given. So you can say E into L is what? V. So E is what? V by L. So here V by L. So here V by L will come. Okay. Now put the value. Okay. So I, current how much? 1.6. Okay. Divided, L will go in numerator. So L will be 2. Okay. N. This N is what? Number of electrons per unit volume only. And he gave it. How much? 5 into 10 to the power 28. E, electron charge 1.6 into 10 to the power minus 19. Right, into area. Area is how much? 0.2 millimeter square. So you can say 0.2 into 10 to the power minus 6. Right? Minus 3 will come, square minus 6. And V. So NEA V. Voltage 2 volt. So that is 2. This is your value. Now this is alpha into 10 to the power minus 3. So your alpha you have to answer. Okay. So let me use another pen. Okay. 1.6 cancel out. 2 cancel out. Okay. And 0.2 is 1 by 5. So that 1 by 5 cancel out. Okay. And here these powers are only remaining. So if you take it in numerator, minus 28 plus 19 and plus 6. Right. So 19 plus 6, 25. Right. Correct na? 25, and 25 minus 28 is minus 3. So I think alpha is 1. Okay. Agree? Yes. That's it. This is your answer. Next. A capacitor P of capacitance, this particular, okay, is charged to 6 volt and is now connected to another capacitor Q of capacitance this. Q has no initial charge. The final charge on Q is. So this kind of question is already in the capacitor chapter, in the notes only, right? So you can look at that. More difficult than this also, reversing the polarity, charging both capacitors, right? Even 3 capacitor question is also there. If you add 3 capacitors together, then what will happen? Okay, so the basic thing is that if a capacitor is charged, I am calling this as C1, okay, and this as C2, okay. This is the V volt, right? First I will solve in variable terms only, and initial charge that will, so this capacitor which have a charge, right? So initial charge that will come, total charge, which will, one capacitor C1 will have, C1, C2. C1 will have, that will be Q is equals to CV. So C1 into V. This is the charge he will carry. Then after, as soon as you will connect, the potential will become, should become equal. So for that, charge will distribute himself Q1 and Q2. Okay. This is the basic thing which we teach in class only, easily. Now total charge Q, that only got in Q1 and Q2. So you can say one thing is Q is equals to Q1 plus Q2. And second thing is, here potential should equal to this potential, right? So here potential, if charge is carrying Q1 and minus Q1 will be there, okay? Here Q2 minus Q2 will be there. So Q1 charge with a C1 voltage. What is the potential? You can say Q is equals to CV, so Q by C. So you can say Q1 by C1 should be equal to Q2 by C2. Okay, and Q1 plus Q2 should be Q. So by these two, if you see, Q1 by Q2 is how much? C1 by C2, means in the proportion of their capacitance. So here you can say he want what? Final charge on Q. That means this one, right? Yes, on the Q2 he want. So Q2 will be C2 divided by C1 plus C2 into capital Q. Okay, put the values. Q2 is equals to C2. C2 how much? 20 into 10 to the power minus 6. Divided by C1 plus C2. So C1 is 10 and this is 20. So that will be 30 into 10 to the power minus 6. Into capital Q is nothing but C1 V1, right? So C1 is what? Again 10 into 10 to the power minus 6. So that means you can say 10 to the power minus 5. And voltage how much? 6. Right? So here if you solve Q2, then how much you will say? 10 to the power minus 6 cancel out, 0 cancel out. Okay, 3, 2, right? And 2 to the 4. 4 into 10 to the power minus 5. Okay, so alpha is 4. Agree? Yes, I agree. Okay, then I hope so. This question is very basic. Not very basic, but doable. Notes question. Okay. Okay, that's all. These are all the questions. So I hope so this is clear. Okay, main you keep in focus that what topic he is asking. Okay, so for time being, I can give you a rough idea, right? Fluid mechanics he is asking. Okay, and this time he asked little bit, not us, I think. Okay, but he is asking fluid mechanics. And one thing I seen the repeatedly is that your current electricity chapter, in that basic formula 2 question came already. Okay, like that. And just keep, when you are seeing these question papers, just see that this concept clear, this concept, just keep the concepts clear. Okay, he will not ask you exact question, he will ask you the same concept question. Okay, so that should be the clear in mind. Okay, and I hope so. And those who are remaining, best of luck for your exam.